Hello, everyone. We've reached another week in our lecture series where you are going to be exposed to and learn more about one of our amazing engineering departments here in the college. This week, we are featuring MAE, Mechanical and Aerospace Engineering. With that being said, about 64% of the population freshmen out there in the audience are going, yay, that's my major, because you are the biggest group of students in our college entering this fall. So mechanical engineering, it's a very, very diverse major. You can go into so many different areas of engineering, biomedical engineering, themed entertainment engineering. You can build rockets, you can build cars, you can be a designer or produce all kinds of products. And then, of course, there's the defense industry. So many opportunities out there for mechanical engineers. Your goal in the next few years through UCF is to try and decide which area, which avenue of mechanical is something that speaks to you and hopefully becomes your passion. For the aerospace students, you know, that is a very, very growing major. You've picked the right place to be. You are in the heart of the space industry, being here in Central Florida, 35 minutes away basically from the Space Coast. The space capital and launch capital of the world is right here, 35 minutes away. I mean, we're the school that watches rocket launches during our football games. So yes, we are very, very much Space U, and we're very glad that so many students are recognizing it and are coming here and taking advantage of all the opportunities that Central Florida and the Space Coast provide aerospace engineers. We are also kind of the capital of the world, you would say, for themed entertainment. Many times when I meet with freshmen and someone will say, I'm from Ohio or I'm from Iowa, and I kind of say, really, what are you doing here at UCF? Many of those students will say, I want to be in the themed entertainment industry. And that is why they came to UCF. So again, those of you interested in that field, you're in the world's capital of theme parks. So great place to be. Additionally, you may not have heard of this phrase, but we have something called the I-4 corridor between basically USF and UCF, the I-4 corridor there, filled with all kinds of industries and companies that offer internships and provide full-time employment for students as well. And then finally, just connected to our campus is the Central Florida Research Park, which is one of the top 10 research parks in the nation. So you can see, MAEs, you've really picked the right school in coming to UCF. It is definitely the place to be for students in your major. So yeah, let's look forward to all the cool things we're going to learn about mechanical aerospace engineering and the cool department that we have here.
Hi, my name is Jeff Kaufman. I'm the Associate Chair and Undergraduate Program Coordinator for Department of Mechanical and Aerospace Engineering here at UCF. I'd like to start off by sharing a little bit about our department. We have a little over 5,000 undergrad students and almost 1,000 graduate students. And it's about a 3-to-2 split between mechanical engineering, just over 3,000, and aerospace engineering, just under 2,000, at least at the undergraduate level. We have 54 full-time faculty members. We have some joint faculty as well as adjuncts from industry who bring their decades of experience into our classroom. Looking at the rankings of our programs, if you start at the larger scale at UCF, we're the number 57 overall best public university. Turning to the College of Engineering and Computer Science, we're the number 71 best undergraduate engineering. Now that's both public and private. But what we really like to tout is that UCF is the #1 supplier to the aerospace and defense industry. We have a lot of students who are going out and doing great things. Something like 30% of NASA Kennedy employees are UCF alums, in fact. Within our department, we have 2 undergraduate programs, the aerospace and mechanical engineering, and they start off the same. So in the freshman year, you're doing freshman engineering, Calc 1, 2, 3, physics, and so on. As you progress through there, you take things like statics, dynamics, thermo, solid mechanics, fluid mechanics, controls, and that's where we start to see some differentiation, mostly in the junior year. So if you're more interested in the aerospace engineering side, you might be more interested in astronautics, more of the space focused, or aeronautics, more of the aviation, air breathing propulsion side. Either way, We're looking to prepare students to develop the next generation of advanced flight vehicles and technologies. As you progress through your coursework, you'll do aerodynamics, propulsion, aerostructures, orbital mechanics, and of course, an aerospace specific senior design project. On the mechanical engineering side, we have students who might be interested in energy systems or mechanical systems, and whichever path they choose, again, we're equipping students to be innovators in the design and manufacturing space. So after taking those same courses that are common to both aerospace and mechanical engineering, our mechanical engineers will take heat transfer, machine design, and then take some second level courses. Maybe it's like heat transfer 2 or machine design 2 or so on. And then a second level lab as well, and then into a mechanical engineering specific senior design project. For both of these, senior design is a 2-semester sequence, and for most students, it's one of the highlights of their undergraduate curriculum. First semester, it's sort of brainstorm ideas, do some pen and paper analysis, perhaps some simulations. Second semester is much more on building, testing, implementing, and actually seeing those ideas come to fruition. We also have a biomedical engineering minor, and you see it's 38 credits. Most of those will also count towards your tech electives for your either mechanical or aerospace engineering. So a lot of our students can pick this up along the way. We also have an accelerated bachelor's to master's program, and this is a great opportunity if you're looking to get a master's after you graduate. You can double count some of your graduate coursework as both your technical electives for your undergrad degree, and then it also counts towards your grad degree. So you graduate your 122 credit bachelor's, and then instead of needing an additional 30 for the master's, you might only need an additional 18. And so you can get a master's in just one extra year from the bachelor's. Most of our students do an internship sometime in their undergraduate experience. And so we have a program that allows students to gain course credit for that internship too. Definitely something that needs to be set up ahead of time. So we want to make sure that we have well-defined learning objectives and student outcomes and so on. But this is a great way to pick up some credits too. Similar to undergraduate research, we have 4 credit options. Even if you don't want to do research for credit, you can also do it for 0 credit, and it still will show up on your transcript as a directed research. After graduating, our students go on to exciting careers in mechanical and aerospace engineering. You can see some of the top recruiters there on the right. Every semester there is an internship and a career fair that is held in the arena. So we said, we saw that most of our students complete an internship, more do research or do something, engage in some other extracurricular activity while taking their classes. And so as they graduate, then we see 70 to 85% are working full time with a starting salary in the range of 65 to 80K, and 20 to 30% are continuing their education. So you might notice that these numbers add up to more than 100%. So some students clearly are doing both of these things, going to work and coming back and getting their master's at the same time, for example. All of our grad courses are offered on video lecture as well. So you can take these asynchronously and work during the day and then catch up on the class in the evening, for example. 5 years after graduation, 95% of our students are working full time with an average salary of 90K. And then by 10 years, that goes up to 120K. And I'll just throw in one caveat on all of these salary numbers. These numbers come from a state of Florida dashboard specific for mechanical and aerospace engineering graduates from UCF. And the survey data was collected, a couple years ago. So add 10% inflation to these to map these forward to the 2025 values. Along the way, many of our students participate in undergraduate research opportunities. So this is a great way to, if you're preparing for graduate school, to help get ready for that. Or maybe you just have, say, 10 hours a week, maybe not enough to do a full internship, but maybe you still want to get involved outside of your classes. And so 10 hours a week is enough to do research and get some experience translating what you're learning in classes into solving exciting, real world applied engineering problems. So whether it's an internship, research, a leadership role in a club, Most of our students are participating in one of these high impact practices, and some even do all three of them. One other thing I'll mention is the study abroad program. So you can do a study abroad for an entire semester. We also have these centers over the summer for a 4-week course. So I'll highlight one here. The Barcelona Center has Dr. Gordon teaching solid mechanics. And so for 4 weeks, you would be in Barcelona learning solid mechanics, experiencing the local culture, and then you come back having another course completed. There's another center in Rome this summer. I believe they're teaching a biomedical engineering course, structures and properties of materials, structures and properties of aerospace materials, as well as an environmental engineering course. So I also want to mention our student organizations. You'll hear from ASME and AIAA. These are the mechanical engineering and the aerospace engineering clubs. We've got a variety of other clubs too that our students really engage in our department. So ASHRAE for HVAC and associated areas. SEDS and KXR are really involved in rocketry. Satellite Club, SAE for the automotive, BMES for biomedical, T is steel for more of the themed entertainment and roller coasters, some honor societies, and a slew of additional clubs too. We don't have space to list them all here, but I really encourage you to get involved with a club. If I can leave a piece of advice that's even broader than mechanical and aerospace engineering, it would be, yes, get involved in a club, but also get to know one of your professors. Better yet, get to know a few of your professors. When you graduate, you're going to need some letters of recommendation or references, something like that. And it's best if you can go back to a professor. So maybe sit in the front third of your class sometime. Raise your hand, say a few words, come to our office hours. I know these things can push us out of our comfort zone sometimes, but it's really a good practice to start early on. And from the faculty side, we love engaging with our students, and it's always neat to hear how where a student ends up and what they're doing. Some of the best days are when a student comes back or even just drops me an email and says, "Hey, 10 years ago you taught me in this course, and now I'm doing this out at Lockheed Martin or at NASA or whatever." It's really gratifying to see what our students go out and do. So we'd be happy to answer questions that you have. We're here in the Engineering 1, room 381 suite, and don't hesitate to drop by. Thanks.
So hi guys, this is Ahmet Özbay. So I'm an associate lecturer at Mechanical and Aerospace Engineering department. I have started teaching in the department in 2015. At first I started as an adjunct faculty, so I started teaching fluid mechanics. The first time in my life I teach a class in front of 250 students. So it was a little bit challenging for me because can you imagine like the first time you get in front of 200 students and like start to teach something. But obviously with the following semester, the next semester I started teaching 2 or 3 classes. And then, I was hired as a lecturer in the department, and right now I'm an associate lecturer in the department, teaching mostly graduate, undergraduate, and graduate courses, mostly aerospace related courses, but obviously my focus is mainly in teaching. So I do what I can do for the students, especially I'm teaching in-person classes, although I'm also teaching mixed mode classes and online classes, but I really emphasize like teaching in-person classes, especially in fundamental engineering courses like fluid mechanics or thermodynamics or aerodynamics classes. These are very fundamental level of classes, especially in aerospace, and fluids also can be an important class in mechanical engineering students. But also when I'm teaching classes, I have a new method for my office hour that I encourage students to come really communicate with me. Not only communicating with me, also communicating with their friends, because eventually it's going to be important, especially for an in-person class, communicating with your professor as well as communicating with your friends. It's kind of an important factor which will be leading you to a success in the class, especially how much you're going to retain from this class is not only limited to going to class. Sometimes even with the best lecturer, that I don't say that I'm the best lecturer, but even with the best lecturer, how much of the content you retain in a lecture? Especially if you're talking about a mixed mode class, you are having once in a week and 1 hour, 15 minutes lectures. And even the best lecturer, you can see that after 1 hour, students losing focus, right? At some point, you're going to be there, you're going to be still listening, you're going to be taking notes with your whatever the professor is teaching, but at the end of the day you are still responsible to learn this stuff, not only going to class. Sometimes students feel like, oh, going to class is necessary. It is the only bare requirement when you're taking a class. Go to class and listen to your professor, take notes. But after the class, we cannot keep track of the students. That's why the best way for me is doing office hours, especially this is a new thing for me. I'm not doing office hours in my office. Instead of taking students individually one by one to my office hours, I am encouraging students come and gather in the atrium, like on these round tables. And also I'm encouraging students to form study groups with like 4 or 5 students, even 6 students. When you're given an exercise sets, assignments or projects, they can work together, because sometimes students can ask questions to their friends much easier. They feel much more relaxed when they're asking the same question to me, because sometimes they're going to be intimidated by their professor, right? That's why I encourage students come and ask me the questions in the atrium hours, so they're going to be feeling like they're as if they're talking to their friend. And they also, when they form study groups, like they share the questions in the exercise sets, so they solve together and they share their knowledge with them. And then if they have any problems, I am here for them. So whenever they have questions, so I can be more helpful to them and they can ask their questions in a much relaxed environment like that, instead of like intimidating in my office one by one, and they feel like, oh, is the professor is gonna judge me, or is this a really ridiculous question to ask? So at this point, pretty much, when they form into groups, they feel stronger and they can come out with the courage to ask questions. Even if it's a ridiculous question, I'm just gonna be telling them, like, whatever you didn't understand, just ask them. Like, and generally, students start asking questions like, oh, this is a ridiculous question. Don't worry about it. I am here to teach you. If you are ready to learn, you shouldn't care about how easy or how ridiculous your question might be. I'm here to teach you. But eventually, the most important thing in here, like doing office hours here and making students gather together, like make study groups and work on the problems together. If you have any problems, come and ask me as a group in here. So it's also very effective, right? Instead of helping students one by one, especially in a large group of classes like 200, 250. I mean, maybe you guys say that, oh, what are you talking? It's not that large, right? Considering the growing amount of students in UCF. But for me, 200, 250 is a still large group of students. It's really hard to help every student one by one. That's why when you do a study group, it can be more effective for me to to reach all the students. At the same time, student-student interaction and the student-professor interaction is going to be really enhanced in this kind of setup. I believe, like, eventually the last thing I can say that, like, don't be afraid to ask questions to your professor. Always interact with your professor, as well as interact with your friends. Like, I have seen some students, they don't even know who are these in their class. They don't really get to meet their friends. You're in the same major, because you never know. A friend, like if he has connections, then through being friends, so you can get connected to different internships just because a friend. Does that make sense? So therefore, student-student interaction and the student-professor interaction is probably the most important thing in college. Thank you.
The UCF Biomechanics Rehabilitation and Interdisciplinary Neuroscience Lab, or the Brain Lab, strives to help people get out and move about by developing technologies that help promote better brain and muscle activation patterns and body movements. We start by trying to understand how the brain, muscles, and body work together to help people maintain their balance and also walk in changing and uncertain environments. Using a treadmill that can shift side to side and pitch up and then down and create tiny slips and trips, we can probe how well the body anticipates, detects, and responds to these perturbations during walking, stepping, and standing. To study brain activity, we use electroencephalography, EEG, and we develop new ways to improve the EEG signals, such as using phantom heads and then recording noise simultaneously with the brain signals. Recording all these signals, we generate a lot of data, and we need custom MATLAB and Python codes to do signal processing to help us get better brain signals. In addition, we record noise a lot like noise canceling headphones work, because we believe that there's information in the noise that we can extract using machine learning. Several of our new projects are focused on getting us out of the lab and into the community so that we can show older adults and other clinical populations information about how they move and how they coordinate their muscles and also their brain activity. We are using EMG sensors to measure electrical muscle signals and have developed a biofeedback display to show independent muscle control and then coordinated muscle control. And we hope this better illustrates and conveys how well someone can control these muscles, which is important for balance and walking. In another project, we are using a system we developed that uses VR with a differential drive cycle setup where the users steer through their leg movements. And we think this will help us understand how people use and learn to coordinate their leg movements. And then finally, to help us better understand brain activity among people walking in the community, we have worked with a company to be able to record both EEG and noise signals with a quicker and easier EEG system. Students in practically every engineering field offered here in CCS, biomedical engineering, mechanical engineering, aerospace engineering, electrical and computer engineering, computer science, and even civil engineering have contributed to the interdisciplinary research in this lab.
So the reason I got into research was that it provided a lot of different opportunities for growth in terms of both skills and interpersonal connections. And some of the skills that I ended up learning was a lot of coding with this project, actually, a mix of Python, Arduino, and C#. And I actually had an undergrad here in mechanical engineering, and I was able to build this system using those skills as well.
I got into research because I wanted to discover new ways of helping people with neuromotor diseases with new cutting-edge technology. I started with a biomedical sciences background, actually, but I felt complex problems require interdisciplinary skill sets. I've explored brain and muscle signals to better understand motor control and also to help people better understand their motor control so that they can have a more individualized approach for their own healthcare.
When I first started in research, I was studying mechanical engineering undergrad, and I just wanted to understand how the human body worked in terms of physics, especially for rehabilitation and accessibility purposes. For my current project, I'm learning to read and analyze EEG and gas exchanges along with other biosignals, and expanding upon the coding knowledge that I got from my mechanical engineering background. And I look forward to using these skills in the workforce to help rehabilitate and create accessibility devices for people who need them.
I wanted to do research because I wanted to explore the things that I'm curious about in a systematic manner. With the research I do at the lab, I have learned biosignal processing techniques. I learned to code in MATLAB or Python to analyze my data. Also, I'm learning how to come up with scientific hypotheses and then ways to test it on a scientific manner. and I'm hoping like these skills will help me in my career goals.
The reason I got into research was because I wanted to try and answer questions that didn't have like defined answers. And then I would say what I learned most about this project, or from being in the lab, is coding skills, and then time management, and then problem solving, because it seems like there's a lot of problems, and yeah, I just have to try and solve them basically. I got my undergrad in aerospace engineering, and I'm getting my master's in biomedical engineering. And eventually I want to go to med school. So in aerospace, I learned a lot about like CFD and FEA and different skills like that. And then in this, I'm learning like a lot of coding, a lot about the human body. And then I think that'll help me a lot in my future.
In the UCF Brain Lab, engineers of all backgrounds work together to understand how we balance and walk. And we hope this will help people get out and move about and live fulfilling lives, which is something we think is important to all of us.
My name is Yue Wen. I am an assistant professor of biomedical engineering at the ME department. At our lab, we combine artificial intelligence, neuroengineering, and robotics to create intelligent wearable robots like prostheses or exoskeletons. Our goal is to improve people's quality of life with those advanced technologies to provide personalized care, support, or rehabilitation.
So, hi everyone, my name is Clara. I'm a PhD student of biomedical engineering in the Wen Lab, and my research focuses on human movement and how to maximize gait so that we can keep families moving forward.
Hi, my name is Jasmine Chung. I'm a mechanical engineering student here at the Wen Lab and undergraduate researcher. My project is on the design and validation of an adaptive ankle rehabilitative exoskeleton. I've been here for about 1.5 years now.
Hi, I'm Delta. I'm a senior mechanical engineering student and I work at Wen Lab. This is my open source leg project. It's meant to restore normal walking gait. I presented this at the Student Scholar Symposium and I did win the Judge's Choice Award. This lab has really helped me hone my skills of designing, controlling motors, and working as a team.
So that's the high-density EMG quadricenta, and it can record 400 single electrodes at a time. And this is the electrode itself, and each electrode has 64 pins on it, that each one of them basically measures the tiny microvolts that come from your skin when your muscles contract. So when he squeezes, it shows that exactly which areas are basically activating the contractors are being activated, and it sends a little bit of tiny voltage signal to the electrode pad. So the point is to record this data and use it for decomposition to actually be able to control other robotics, exoskeleton, or prosthetic through high-density EMG signals.
Hi, my name is Hua. I'm a ME PhD, and my study at Wen Lab is I research on digital twin, which is a representative of human and robot in a virtual environment. For example, I can get a data of the person walking, and I can use machine learning or AI to control a controller that acts just like that person. As you can see here, like this is using muscle control to act like a person walking. And then I can elaborate on the task that I give the controller. For example, I train a person walking up the stairs. And then I can introduce robotic system to train controller for robotics and to adapt to different people, like the one you see here.
Hi there, I'm Dr. Anthony C. Terrasiano. I'm a triple UCF alum from the Mechanical and Aerospace Engineering Department. I got my bachelor's degree in 2013, my master's in 2014, and my PhD in 2016. You all have taken on a wonderful journey towards your career. You're getting a degree at UCF in engineering. Congratulations to you. You have done one of the hardest things that you need to do, starting on your journey. With that being said, this is not the end of it. You will continue and you will persevere. Your greatest assets are those in the classes above you. You can ask them all kinds of questions. Approach them in the atrium. Ask them when they're getting internships. Ask them when they're graduating. What kind of pay are they getting? Figure out where you want to work. If you are looking online at jobs right now at Intro to Engineering, you can build your skills to the job you want, where you want to live. It's very important. With that being said, for those of you that are going the academic route and intend to get a PhD, you're a special breed, and I wish you the best. It will not be easy, but you will make an impact. Get it done and enjoy the time you're doing it. One of the other important things, go have a social life. What will get you ahead is not being the technical expert in whatever it is. That's extremely important, but being able to talk to people from all walks of life is even more important, because there's a chance that your manager is not going to have the same background that you do, and you can learn something from them. At the very least, you can listen to what they have to say, and you will know how to respond, and it will help you.
Hi guys, and we're also going to be part of this alumni segment since we are both alumni of the MAE department. We both have our bachelor's in mechanical engineering from the University of Central Florida, so we just want to kind of give you an idea of what we're doing with our degrees now.
So I am big in automotive. I've done four internships with Ford at this point, and
with a full-time offer.
With a full-time offer, I'm starting in March. So I'm doing design of vehicles. I'm interfacing between the people that sketch all the vehicles and the actual engineers that build them. I'm sitting right in between and communicating from one side to the other and back and forth, kind of manage the project. But I've also done project management internships with my degree as well. And then Ella, you're biomed, right?
Correct. So I'm actually on the biomedical track. So very different from automotive, just to give you guys a spectrum of what you can do with a mechanical engineering degree. I had an internship where I was jumping around different rehabilitation facilities around the Orlando area. I got to come up with new design ideas to help patients, to help the rehab, like the facilities, the actual physical therapists, the occupational therapists, things like that. So that was a really great opportunity, and now I have a whole lab where I'm getting to go to an anatomy lab. I actually get to work with the human body and different parts of the cadavers and things like that. So it's a really great opportunity, and it's definitely a big change. But it's just a great way to use your mechanical engineering degree if you are interested in biomedical.
Yeah, the world's your oyster, especially within mechanical engineering degree. Aerospace, you're very focused on aero, but it still allows you that flexibility. But with mechanicals, I can talk to some of my friends that have graduated. One of my friends, she graduated with mechanical, thought she wanted to go into biomed like Ella and get her PhD. She ended up changing her career path to architecture and really loves it. So she's doing HVAC work and all of that. I've got 3 friends who graduated in aerospace, and they're working over in Vasu Labs here on campus doing research in hypersonics. Some of our TAs, like Belle, she's working at Blue Origin. Another one of my friends is there. And then my friend Patrick, he's over at Lockheed Martin doing project management there too. So there's so many different opportunities that you can take, and those are just a few of them. Yeah. So if you're interested in mechanical or aerospace, go talk to Dr. Kaufman, go learn more, talk to us or any of our other TAs that are in that degree program as well.
Yeah.
Hi everyone, my name is Amelia Suraga. I am the president of the American Institute of Aeronautics and Astronautics, and let me tell you a little bit about who we are and why you should join us. So who are we? We are UCF's student branch of the American Institute of Aeronautics and Astronautics. We are one of the largest student branches in the country. We focus on hands-on aerospace projects for all skill levels, and we also do monthly guest speakers, professional development events, socials, and more. But let me tell you a little bit about some of the projects we offer. First up, we have aviation vehicle design. This one is focused on designing and building an RC aircraft. First, it is 2 semesters. So first semester is the research and design phase, and second semester is manufacturing. Rocket design teaches you how to design, build, and launch a mid-power rocket. It is a 1-semester project running in both fall and spring. In conjunction with this, we also run a level 1 high-power rocketry certification workshop, so you can get your L1 certification, which is something that looks really good on your resume, so definitely check that out. Next up, we have quadcopter design. This one teaches you about designing, building an FPV quadcopter, and you'll get to fly it at the end of the semester. Hovercraft design is teaching you how to CAD and build a hovercraft. This semester's challenge is soccer, so if you want to try and play soccer with hovercrafts, definitely join us for this one. VTOL is an experimental project that is trying to design and build a vertical takeoff and landing RC aircraft. They are in their research phase right now, so definitely join them for that. They will hopefully start building at the end of this semester or beginning of next semester. Project Horizon is a experimental project as well. They are a high-power rocket project, and they're trying to launch to 45,000 feet to capture live video of Earth's curvature. They're in their research phase and about to do their preliminary design review, so definitely check them out. And last but not least, we have Design, Build, Fly. This is a national competition run by AAA National. It is a RC aircraft competition, and this year's challenge is to design, build, and fly a cargo and passenger aircraft that can tow and release a banner midair. So definitely come and help us out if you want to help with the competition. So in summary, here are our projects. Our social media and email and website are listed there. If you want to join us, definitely scan that QR code, join our Discord. That is where we send out all of our major communication, and we hope to see you guys there.
Hi everyone, my name is Michael and I'm the Vice President of UCF Steel. We are the Society of Themed Entertainment Engineers and Leaders, STEEL for short. We focus on design, manufacturing, and maintenance in the themed entertainment industry, roller coasters, restaurants, scenic, anything you can think of in a theme park scenario like this, that's what we work on. At STEEL, we do projects, we have speaker events, we even have socials where you get to come to places like this.
Hi. I'm Sammy, and I'm the Technical Skills Lead here at UCF Steel. At Steel, we run a number of different things to help you with your professional development, including projects, workshops, and especially our spring competition projects.
My name is Joe, and I'm the secretary for Steel this year. We have tours all the time in Steel of different places in the industry, whether it's at parks, at distributors for the parks, or at any sort of areas in the industry. This really big panel we have coming up in the middle of November that I would urge everyone to sign up for if you connect with us on social media.
So, if you guys are interested in Steel, please feel free to join us, become a member today. Check out our GBMs, check out some of our tours and projects, and we hope to see you soon.
Hey guys, it's Zoe with the Night Special Effects Club, or KSEC. Just a quick reminder that we do have our second GBM on Monday at 5 p.m. in the Libra Community Center. Looking forward to seeing you there.
Hey guys, welcome to TA Spotlight this week. My name is Tristan.
And I'm Anthony.
I'm currently a junior here at UCF studying mechanical engineering with a minor in math. I do research on campus. I have a couple club affiliations. I'm an officer in KSEC, and on my free time, I like to go out, play sports, mountain bike, and play soccer.
And I'm a senior aerospace. I'm pretty involved with school too, but I have a office position in Mexican Student Association, so if any of you are interested, please come out and see us. Out of campus, I like to play soccer. I go to the gym. I like to watch sports, stuff like that. And yeah.
Cindy, give the class a fun fact about yourself.
A fun fact? I've once hiked for 12 hours in Yosemite. I'll give a fun fact about yourself.
I myself I'm really into cars, and I'm currently on my third transmission and blew up one motor. So hopefully, I'm on a motorcycle right now. Hopefully, this doesn't go bad. Hoping for the best. Thank you guys so much. We're sending off to GTAs now. Have a great day.
Hey guys, welcome to Go for Launch with the GTAs. We're back where we were in our first lecture in the atrium, one of our other study spots with the whiteboard tables, really great for collaboration. But this week we're going to speed run those announcements. I don't have a Panera green tea to chug, but we're going to go through quickly. So today you heard from Dr. Kaufman about the MAE program, Dr. Osbey about going to office hours and study groups.
And then you also heard about the alumni, including both of ourselves, along with Dr. Anthony. And then you also got to learn about 2 research labs. You got to learn about Dr. Huang's lab and Dr. Wen's lab, both biomedical engineering labs.
For clubs, you heard from ASME and AIAA.
As well as STEEL, and then a little reminder from KSEC.
Make sure to check that out. Also, make sure to go tonight to the SolidWorks Club. They're in HEC 125, 7 o'clock. Yep. Go check out their meeting. They're opening up more signups for their trainings. You heard from the TAs, Anthony and Tristan.
A weekly reminder of SimNet Chapter 7 being due this Sunday at 11:59.
Next week on Monday, homecoming voting starts opening up on my UCF, so go make sure to do that and vote for your homecoming royalty.
And then you also have all of those fun homecoming events like Spirit Splash, the concert, comedy night, and the homecoming game itself. So make sure you guys are attending those if you can.
Yep. Remember, you do have to go to class. If it's scheduled during that time, you can't get out of class to say to go to Spirit Splash. You have to show up. For next semester, the course, your lecture is still going to be online in this same format. We're going to try to keep it fun and fresh for you guys week to week. But as you're registering for your courses, we want you to be aware we've gotten a lot of questions about that.
Yeah. And now, here is your quiz code.
Have a good weekend, y'all.